actually not going to be anything too crazy. We are talking about average value. So if I ask you to find the average of something, what do you do? So if I ask you to find the average homework score. All right, add them up and divide by the number of items you started with. So if I wanted the average score, you would add up all the scores and divide by the number of students. Okay, but those are a finite value, right? We have a set number of people in this class. So we have to think about what if we have an infinite number. So if you think about like average temperature. So if I ask for the average temperature in a day, how do you find that? Are there a set number of times in the day that we could calculate the temperature? And you could find the temperature every hour. You could find it every minute. You could find it every second. Could you measure the temperature every half second or quarter second or eighth of a second? Yeah, but you could. It's a continuous value, right? So we can't just say, oh, I'll add up all the temperatures and divide by the total, because there are an infinite number of values that we could have added up because it was continuous to start with. So let's think about that. If we're kind of going with this, we talked, if I said, well, average value, we add them up, I could add up once an hour, add my temperatures and divide by 12. If I said, nope, that's not enough, I need to check every 30 minutes. I said 12, let's do a full day, about 24. You guys didn't even catch that, did you? No. So if I said, well, maybe once an hour isn't enough, we need to do every 30 minutes. Then I would add up my temperature every 30 minutes, and what would I divide by? 48. Or if I said, no, that's not enough, let's go every 15 minutes. So we would add them up and divide by. Okay, so what's happening there? I'm adding up more and more values and dividing by something bigger and bigger, right? Does that at all remind you of when we calculated areas and we had the number of rectangles and we made the number of rectangles get, the size of our rectangles got smaller and smaller, so we had more and more and more of them. And then eventually we said, well, finding the area under this curve, that's really just an integral, right? So I could integrate, but then to find the average value, you have to divide by something. So the notation, they say f and then AVE as a subscript, that means the average value, is 1 over b minus a times the integral of your function. So basically we're going to find the antiderivative like we've done, and then we're just going to divide by the length of the interval. So that is our average value. That's what we're going to be doing today. All right. So let's say I wanted to look at this one. Okay. Get prom all done? All done tearing down prom? Sound out of breath. So if I want my average value, I'm integrating my function from where to where? Of your function. We're not doing anything fancy there, so just like this. But that would just give me the total area. So then what do we do to make it the average? So the definition of the average value is basically we're dividing by the length of the interval, or we'll multiply by 1 over 2 minus negative 1. So that gives me a 1/3 times antiderivative of 1 plus x squared. Negative 1, 2. Alright, let's keep that 1/3 out in front. So if I put in a 2, I get 2 plus 8 thirds minus negative 1 minus 1 third. So, 1 third times 18 thirds, so 18 over 9 is 2. So my average value is 2. Is that one okay? Let's try another.
Wait, why did it change to minus? Wait, never mind.
Are you sure?
Yeah. Wait, yeah. No, I'm not.
Okay.
Why, the second parenthesis, why is it minus?
So, my next question. Would there be a number c at which the value of the function is exactly equal to the average value of that function? Okay, in other words, what we just found, our particular function on the interval from -1 to 2, we were looking at 1 plus x squared, right? And we found that the average value was 2. So my question is there something that would make the function actually equal to? Yeah, if you subtract over your 1, square root, plus and minus, and you get positive and negative 1. If we are looking specifically from -1 to 2, both of those are technically in our interval, right? So it actually equals that value twice. Would that always be the case, do you think? Would your function have to equal your average value at some point? We've kind of talked about average values a little bit before, back when we talked about like mean value theorem and things. And I think the example I gave was, okay, if you take your car and you drive to Hannibal, and your average speed is 62 miles per hour. Could you hit an average speed of 62 miles per hour without ever driving 62 miles per hour? No. You would have to hit 62 at least once in that interval, right? Could you hit it multiple times? Absolutely. Because your speed's going to fluctuate. So when we're looking at these continuous functions, mean value theorem says as long as you have a continuous function, then your average value will be equal to a point. Your function will equal your average value somewhere in that interval. So, I guess I kind of got ahead of myself because I already did this. Sorry. So write down what I just wrote down if you didn't already. So we did, for our particular case, the 1 plus x squared. We found that equaled the 2, which was our average value. And we got positive and negative 1. And since both of those were in the interval, those are the two cases where the function was equal to your average value. Those are good. Okay, I was just saying this in the ones that we're doing before. All right. I'm going to skip that one. I'm going to go to this one. I want to find the average value of the function x squared on the interval 0 to 2. Can you guys do that? Yeah, try it. Try to do the average value. What'd you guys get? 4 thirds. So we are integrating, or been thrown around. from 0 to 2, x squared dx, but in the front, you have to do, because I said at average value, 1 over your ending minus your beginning, so we have 1/2. Antiderivative of x squared is 1/3 x cubed from 0 to 2, so that's 1/6 times 2 cubed minus 0 cubed, so 8 over 6 or 4 over 3. So that's good. We're going to try just a couple more. Alright, in Athens, Georgia, the mean daily temperature in degrees Fahrenheit T months after July 15th is closely approximated by this function. So this is our temperature. Find the average temperature between September 15th and December 15th. Okay, average. So, September is how many months after July? August, September, so 2 months. December would be when he is. July is August, September, October, November, December. So we're going to integrate from 2 to 5. So what would I have to put in front? Yep. 1 over 5 minus 2, or 1/3. And then we're just integrating this function. Antiderivative of 61 would be 61t. Okay, let's talk about this. What has a derivative of cosine? Sine. So the angle wouldn't change. That's a pi over 6t. Okay, so when you do the chain rule, it would multiply by a pi over 6. So we need a 6 over pi in front times the 18. So 18 times 6 would be 108 over pi. Okay, and I'm going to assume this is not beautiful, so I'm going to use a calculator. Make sure you are in radian mode. What'd you get?
This class 2 classes for them.
It would probably be easiest, because this one's so ugly, I wouldn't do the 1/3 until the very end. So you do your 61 times 5 plus 108 over pi. Sine, you plug in your 5, pi over 6. You have to close both of those. You probably just dropped a parenthesis somewhere, honestly. And then once I did all of that, I get that answer and then multiply by the 1/3. And you should get about 56.8 degrees. So despite the ugly calculator problem, which on the plus side, you wouldn't have that on a test, did you get the calculus behind it? Understanding how to set it up and what we're integrating. Okay, we're going to do 2 more examples, and we're going to talk a little bit about our quiz and give you guys some time to work. So the next one, I want the average value of g of x equals x to the negative 1/2 on the interval 0 to 4. Sorry, 1 to 4. So I'd integrate from where to where? 1 to 4 of x to the negative 1/2 dx. And what do you think I should put in front of here? 1/3. 4 minus 1 is 3. Alright, So if I add 1 to my power, that's a 1/2. So it gets a 2 in front. So we should get an average value of 2/3. I'm going to add a question to this. So your quiz tomorrow, I told you there'll be 2 questions from this section. So one of them would probably be a very straightforward like this, find the average value. The only other thing, what if I said find C such that the average value is equal to f of C for example. Alright, so all I'm asking you to do is find out when does the function actually equal the average value. Okay, so we have to have the average value, but we just found it, and that's 2/3. So I'm just saying, when does the function, which the original function, x to the -1/2, when does that equal 2/3? What's a -1/2 mean? Okay, so I get square root of x equals 3/2. How do you get rid of a square root? Square. So 3 squared is 9, and 2 squared is 4. So 9/4. Was 9/4 between 1 and 4 to start with? Yes. So those are probably the 2 types of questions that I would ask about this function, or this section. You know, finding an average value, finding a point where the function equals the average value. Is that okay? Let's do a quick recap over the other stuff and then give you guys some time to work. So if I said, just for the record, I am making this up, okay? So.
Right? Oh. Calculus is always the most calculus. Oh, yeah.
Alright. So what does y equals x squared look like? Just a rough sketch. Tell me what that would look like roughly. Parabola. Okay. We could go ahead and find out where these. I said error. I meant area. Sorry. Let's go ahead and find out when these meet. So I'm gonna know when x squared equals 8x minus x squared. So if I bring everything over. We get x to equal 0 and 4. So just a rough sketch, like I'm not looking for anything fancy here, so 0 squared, if I plug a 0 in here, and if I plug in a 4, I know they're roughly the same. Even if you just did like one number in between, if you put in a 1, you get out 7, so you know that's above the other curve, right? And this is really all I need. Now, if you messed up, how do you know if you have the wrong curve on top when you actually integrate? You get a negative. And how do you fix it? Opposite side. So I would integrate from where to where? And we do top minus the bottom. So the top curve minus the bottom curve. Not for area, that's for volumes. So area, we're just doing the curves themselves. You do have to watch if they meet more than one. Like, what was, we did one, like x and x cubed, or something like that. So if they meet multiple times, you'll have to break up your intervals. So if you had something like this, you have to go from here to here, integrate that part, and then from here to here, integrate that, and add them together. Do you guys know how to finish this? So areas is just very straightforward. Find the intersection, top minus the bottom. If they have multiple intersections, make sure you integrate each little piece, because the top curve might switch. And then the volumes, we did one at the beginning, so we know if we're integrating around a vertical line, we do it in terms of, if you're integrating like the y-axis, you would do it in terms of y. If you integrate around a horizontal line, we do it in terms of x. Do I need to do a practice volume?
No.
What if I just, let me give it just a generic, I won't work it out entirely. Let's say I said y equals 5 minus 2x bounded by y equals 0, x equals 1, x equals 2, rotate it around the x-axis. So what's this graph? A line. Y equals 0, so y equals 0, that's just the x-axis, right? X equals 1, so if I put in a 1, move it out. 3, if I put in a 2, we get out 1. So we're taking that little piece, bounded by the axis, so we're taking that, rotating it around the x-axis. So you get something like this. So when we do volume, where would I start and stop this one? From 1 to 2. Of pi, all of these, the cross section would be a radius, so we're doing area of a circle. Sorry, cross section would be a circle, so we're doing area of a circle, so pi times the radius squared. What's the radius in this case? And then we would just integrate that. And then we did at the beginning of class 1 with 2 functions, and you had the area between them, so you do like top minus the bottom. And you integrated. Okay, so I might do 1 or 2 problems at the beginning of class tomorrow, just as a refresher. So here is your assignment. On problem 9, it has an A, B, C. You only need to do A and B. C asks you to draw a rectangle.